In our next section, we're going to begin our discussion of IPsec implementation on the ASA. Specifically, we're going to look at first the IKE version 1 VPNs on the ASA. We're going to talk about how the tunnel groups and group policies work, and as well talk about some of the different inheritance rules when we're dealing with our default tunnel groups or default group policies, and then when we have user-defined tunnel groups and user-defined group policies. Now, in general, the way that IPsec works on the ASA is kind of like a mix of the iOS implementation and the legacy box that is the VPN 3000 concentrator. Like regular iOS, ASA is going to use the ISACamp policies where we're defining our different things like the authentication type, the encryption, the hashing, and the Diffie-Hellman group. We're also going to be using crypto maps similar to iOS where we specify what is the peer that we're sending the tunnel towards, what is the proxy ACL, the proxy identity that controls what type of traffic that goes in the tunnel. But the difference that comes from the legacy concentrator are their notions of the tunnel group and then also the group policy. Now these we'll see are going to be most useful when we're dealing with any type of remote access VPN, whether this be an easy VPN IPsec config or whether this be a web VPN or SSL VPN based configuration. Now with the ISACamp policies and the crypto maps, as I mentioned, these are going to be similar to the iOS implementation, and just like in iOS, the ISACamp policy defines our phase 1 parameters. So again, those 4 options that we need to match on both ends of the peer: authentication, hashing, encryption, and the Diffie-Hellman group. And just like in iOS, these are going to be processed top-down until a match occurs. So if we have multiple policies, if we have ISACamp policy 10, 20, and 30, we're first going to check policy 10. If that doesn't match, go to 20. If that doesn't match, go to 30, and so on and so forth until we run out of policies, and then ultimately the proposal would be denied. Now, likewise, in similar to iOS, the crypto map is then going to define the phase 2 negotiation, which first is going to be who is the tunnel going to. That's going to be the peer address. What type of traffic is going inside of the tunnel, which is going to be our proxy identity or the proxy ACL. And then how is the traffic going to be treated, which is our IPsec transform set. Now, one of the minor differences that you could get tripped up on if you didn't know that this was the case is that in a regular iOS, ISACamp is enabled as soon as you enable the crypto map on the interface, but in the case of ASA, this is not the case. So we would have to apply the crypto map, but then also need to manually enable ISACamp on your interfaces, where typically this is normally going to be the outside interface that we're applying the crypto map on, and then also applying, or enabling, I should say, ISACamp on as well. Now, beyond iOS, where we are moving into the legacy VPN concentrator features that got ported over, the tunnel group in ASA, you could think of this loosely like the ISACamp profile in iOS. And in other words, this is basically the profile that an individual connection is going to get. Now we'll see that the different types of attributes that a tunnel group is going to get really depend on what type of tunnel is it. So is it a LAN-to-LAN tunnel? Is it a remote access tunnel? Is it a SSL VPN tunnel? There's going to be different ones that apply depending on what type of connection it is. So we'll see that those are going to be under the individual IPsec attributes or the web VPN attributes. Basically what this is going to do is when we're doing our IKE negotiation, so during our phase 1 ISACamp negotiation, based on the ISACamp identity, which would be something like an IP address or a certificate if we're doing PKI, we're going to match that information against these tunnel groups, and then that is going to determine what are the different attributes that apply to this individual connection. So for example, we could say based on the host name, choose a particular pre-shared key. Or based on the certificate, choose which particular certificate authority, trust point, you're going to check the validation against. Could be also AAA, like based on our easy VPN users coming in, they could go to maybe one radius server, and then the web VPN people coming in, they could go to a different radius or TACAC server. Okay, also this would be where we assign the IP addresses for the remote access VPNs. So is it going to be some local pool? Is it going to go to DHCP? And then also, what are the specific policies that are then going to apply to those individual users, which is considered to be the group policy. So the second portion then, which is the group policy, is going to define what happens once the tunnel is actually established. So after we've gone through the ISACamp negotiation, once we've done our authentication and we move on to the rest of the negotiation, this would be things like, are we running perfect forward secrecy? If we're doing remote access VPNs, are we doing split tunneling? And if so, what are the particular destinations that they can split tunnel towards? This would also be where we would apply a VPN filter. VPN filter is basically a data plane access list that you could apply onto the tunnel itself. So I could say, for example, when the EasyVPN user comes in and they land on group policy accounting, apply an access list to them that allows them access only to the servers that are for the accounting group. So you can match on not only the things like what authorization are they going to get, so what authentication server do they go to, but then once they return the authentication authorization, say yes, they're allowed to get in, we can go further into that and say, for this user, download a particular ACL from Radius, and then it's going to be applied as a VPN filter under their group policy. This is also going to control what tunneling protocols can we use. So you could say, like on a per user basis, is this user allowed to do SSL VPN, or are they allowed to only do EasyVPN? Okay, then any other, basically any attribute you would normally assign to a remote access user, this is going to be where everything is defined there under the group policy. So like if we wanted to do split DNS, something like that. Now these options can be configured locally, or they could be attributes that are coming from AAA. And you define this whether the group policy is an internal or external group. Internal meaning the local database on the ASA, external meaning like your Radius server. Then you specify what are these individual attributes. So we'll see once we get into remote access, most of these group policy things are going to be relevant just to the remote access VPNs, because when you're doing LAN to LAN, it doesn't make sense that you would get split DNS necessarily, or that you would get SSL VPN. That of course is going to be for remote access users. Now the potential issue that we'll see with these tunnel groups and the group policies is that they're not really that syntax friendly. It's not very straightforward to do a lot of this configuration from the CLI on the ASA. And we'll see from like the SSL VPN point of view, a lot of that is really meant to be configured from the GUI of the ASA and not necessarily the CLI. So some of the syntax can get pretty cumbersome. So what I would personally recommend is not to try to memorize what is the syntax for the tunnel groups and what is the syntax for the group policy. And the reason why you don't need to memorize it is there's a couple ways I'm going to show that you can use not only the documentation, of course, but the CLI itself in order to figure out what is the syntax I need to use on the ASA in order to build these tunnels. Okay, so of course we can use the Cisco docs, and I'll show what are the relevant documentation pages that you may want to look at. But there's also a command in global config of the ASA VPN setup that asks you a couple questions, and then it spits out a templated config that says if you're doing IPsec remote access for EasyVPN, here are the basic steps you would go through in order to complete this config. The other one that is going to be very useful is show run all for the tunnel group and show run all for the group policy. So just like we were talking about in the modular policy framework, you don't want to memorize what is the syntax for the regular expressions for application inspection, and you don't want to memorize what are all the default inspection policies, stuff like that. So make sure that you are comfortable with looking at the show run all for these different features, because once you look at the syntax, it's pretty self-explanatory what the options are. It's just that there's way too many options for you to memorize to begin with. So let's take a look at this real quick on the CLI for the ASA. If we go to global config and we say VPN setup, and it asks you what type of VPN do you want to form. So do you want to do a site-to-site, which would be a LAN-to-LAN config? Is it an IPsec remote access that would be for our EasyVPN? Or is it an SSL remote access. That would be for web VPN for AnyConnect SSL. So in our case, we're doing site-to-site, which is our LAN to LAN. So show me the steps that I need to go through to get there. It says, first off, make sure you configure the interfaces. Okay, self-explanatory, they need IP addresses, they need names, they need security levels. Then it says configure the ISACAMP policy. And this is very similar to what you would see in regular iOS. You can actually copy and paste these between the two different platforms, the ISACAMP policies. Very similar with the transform set. You'll see the syntax is a little bit different where you can't copy and paste 100%, but if you question mark through it, it's pretty self-explanatory what the transform set is doing, where this is, again, where you would determine what is my encryption technique and what is my authentication. So am I using single DES, triple DES, AES, what is the key length for AES, and then am I using MD5 or SHA. Now, if you look at the details here for the transform set, if we say crypto IPsec transform set, let's say my set like they have, and look at the question mark, crypto IPsec. Oh, IKE v1. We need to say IKE v1 transform set. And transform set ABC, you can see that it does not support authentication header. So again, you normally wouldn't want to use AH to begin with because it doesn't support encryption. One of the few applications that is left of that is going to be for routing protocol authentication in IPv6. So you could see just based on what the CLI shows here for the ASA, 99% of the times we're assuming that we're talking about ESP when we're talking about forming our IPsec-based VPNs. So again, if we go back to VPN setup and look at the IPsec, not remote access, we want the site-to-site steps. So once we configure the ISACAMP policy, we configure the transform set, we configure the tunnel group. We're going to go through in detail what are the different options you can have under here. You bind it together with the crypto map and then you apply it to the interface. So even if you've never done this before, as long as you understand how IPsec fits together, what are the different pieces of the logic, you can kind of stumble through the syntax just by using the VPN setup. The other shortcut for this, like I mentioned, is going to be the show run all tunnel-group and the show run all group-policy. Now we're going to get into more detail in these in a second here, but if we look at just briefly, we can see what are the default ones that are built in. This one is the default L2L for LAN to LAN group. It says the type is an IPsec LAN to LAN tunnel, and by default it says that you're going to use this group policy. And the specific IPsec attributes would be that there's no default pre-shared key, there's no default certificate authority trust point, there's no local authentication, no remote authentication. So basically what you could do if you wanted to would be to come to this default policy. You could say the IKE v1 pre-shared key is Cisco, and that would basically be like a fallback password for any new tunnels that you create. So we'll talk about some of the inheritance rules. It can be a little bit complicated here, and there's some differences between the tunnel group and the group policy. But the main point being here that you don't need to memorize all of the syntax, and especially when we're dealing with, again, the remote access groups, you don't want to try to memorize this. There's too many options under here, and just by looking at the defaults, it's self-explanatory what these do. Like, what's the IPv4 address pool? This would be if I want to assign an address to an EasyVPN remote peer. Or what is the DHCP server if I don't want to assign it locally, forward it to some internal server. Okay, the other one that we would look at here is, besides show run all tunnel group, is show run all group policy. So again, the group policy is mainly going to be for the remote access VPNs because there's things like what are the hours of the day you're allowed to log into the VPN. So maybe 9 to 5 Monday through Friday. What's the access list and the data plane that applies to that individual user. And then other things that might apply to LAN, like perfect forward secrecy would be one. Then also for remote access, this is where we would do transparent tunneling. So if we want them to go through not NAT transparency, which we'll talk about later, but this is this is transparent tunneling, we could say have the ASA listen on port 10,000 for our phase 2 actual data plane, which would be tunneling ESP inside of UDP. And the other one that's going to be very common is the split tunneling policy. This is where you would say, I want the remote access users to be able to send their traffic to the internal destinations, but when they route to the internet, use their local connection. Don't send all the traffic over the VPN and then have me have to hairpin it back out to the rest of the public network. But as you can see, without having then to go through all the individual documentation pages, you can kind of just question mark your way through these and figure out what you would need to change for a specific requirement. And again, those two commands are show run all tunnel group and show run all group policy. Now, getting back to some of the specifics about the tunnel groups, the tunnel name is going to be matched against, and I'm talking about here when the ASA is receiving an IKE request inbound. So it's someone else is trying to initiate a tunnel into the ASA. The ASA is going to match the name based on the IKE identifier. So this means that if the remote router or the remote ASA is using its IP address as the IKE identifier, the tunnel name would be the tunnel group name would be the IP address. If the tunnel group name is a host name or a fully qualified domain name, then we would have to run, we could run aggressive mode, which is going to send us immediately the IKE identifier before we go through establishing the secure tunnel. So mainly this type of matching is going to be for remote access VPNs. When you're dealing with a LAN-to-LAN tunnel, you typically just match based on the IP address. You could also technically match on the certificate, the digital signature, where the OU field in the common name is going to be by default what is matched against the tunnel group. But technically, you can change this. There's a feature that's called the certificate map that you could theoretically match any arbitrary string inside the certificate that you want. So as I mentioned, there's certain cases where the IKE identifier wouldn't be there, and that's when you're doing main mode. Because with main mode, remember, you don't exchange the identities until you actually establish the tunnel. But it's kind of like a catch-22. If you want to use the identity to establish the tunnel, but you can't see the identity until you establish the tunnel, that's really the difference between when you would need to use aggressive mode versus main mode. So if you're using main mode, when you match the tunnel group, you're going to match against the IP address. And again, that's typically going to be for LAN to LAN. But when you're running remote access, you typically would want to use aggressive mode, because then you could match immediately the IKE identifier first, associate that with the tunnel group, and then you know the individual attributes that you would want to apply onto that specific tunnel. So there's some customization that you can get into here, and I'm not going to go through all of the configurations. You can see through the documentation and some of the examples in the workbook labs how this works. But you could say to do the mapping based on the organizational unit or the IKE identifier or the pure address, or you could also create these rules inside a certificate mapping that would specify how do I actually classify the request coming in, and then associate that with a particular tunnel group. But we'll see once we get into the actual configuration of this, both for LAN to LAN and remote access, this is one of the common configuration places that you could run into a configuration error, and the ASA would not be able to find the correct tunnel for the remote peer. So one of the big things we're going to be looking at in the debugs of the ASA is when the connection comes in, we need to make sure that it is associated with, or what the ASA debugs call landed on, the correct tunnel group. Because if we cannot associate the request with the correct tunnel group, then ultimately we're not going to be able to form that particular VPN. Also, likewise, you could match the default tunnel group. That's going to be your default fallback. So like I mentioned, when you look at the show run all tunnel group, you can see the options for the default remote access group. Then you also have the default LAN to LAN group. You have the default web VPN group. And you can see all these options again when you look at the show run all tunnel group. And also this option here, which is the show run all tunnel group map. So this says what are the defaults when I'm mapping the particular users. If nothing matches them, then they're going to fall back to the default group, which is the default remote access group. So you can enable these or disable these selectively. So if I don't want to check the organizational unit inside the certificate and instead do certificate mapping, I would turn the tunnel group map rules on. And then beyond this, you would have to actually define what are the particular rules. Okay, the other thing that's going to be different in the ASA versus iOS is that since we have these default group policies and we have these default tunnel groups, you run into kind of like a logic error when you configure a user-defined group. How do you know where your particular option is coming from? Is it coming from your manually defined group, or is it going to come from the default one? And also, what happens if you change something in the default group? Does that apply to all of the user-defined policies, or does it apply to just the default one? So it's a little bit different depending on whether we're talking about group policies or the tunnel groups. Okay, so the LAN to LAN group, which again is the tunnel group that is type IPsec-L2L, it's going to get its default settings from the default L2L group. Now the key with this is that if you make a change to this, the changes are not going to be reflected onto the user-defined tunnel groups. So if we look back at the CLI for a second here and go back to the show run all tunnel dash group, and we see we have the default, let me scroll up here, we have the default IPsec LAN to LAN group, and let's say for example the pre-shared key. Okay, it says there's no default IPv1 pre-shared key, which would be if our ISACamp policy says do pre-shared authentication, then we check the tunnel group to figure out what's the actual password that you want to use. So if I were to change this here in the default LAN to LAN group and said the default pre-shared key was Cisco, but then I configured a separate user-defined tunnel group, it would not inherit that individual password. So it's really only an issue when you have some sort of discrepancy between what is the default parameter and then what is the user-defined parameter. If you want to be 100% sure of this, you basically could just copy all the defaults and then paste them into the user-defined tunnel group and the user-defined group policy, and then you're always going to know that it's going to pick those specific ones as opposed to falling back to the defaults. But key point here being that if you change the defaults of the tunnel groups, it's not going to affect the user-defined ones. So same with the remote access one. You could change the defaults in the default RA group, but it's not going to affect the user-defined groups. Same with SSL, which is of type web VPN. You can change the default web VPN group, but then if you have specific user-defined ones, it's not going to be reflected in those tunnel groups. Now the default tunnel groups, they're basically a config template, but they can also be used for active connection. So what this means is basically that if the user comes in and they don't match a tunnel group, they will fall back to the default one. So they are going to then inherit those individual attributes from this. And this is the reason why that the changes aren't replicated down to the user-defined groups. But again, you could pretty much see this from the running config that if you look at the show run all tunnel group and you compare the default one with your user-defined one, the user-defined one is going to show you what particular attributes that you have changed that are going to correspond just to that user-defined group. So this will make a little bit more sense when we actually look at the CLI config. All tunnel groups use the same set of authorization attributes by default. This is the default group policy. So what this means is that whether you're dealing with a LAN to LAN group or if it's a remote access group, they're all going to fall back to this group policy. Again, if we look at the show run all group dash policy, there is only one default group policy. So there's different default tunnel groups depending on what type of tunnel that we're dealing with, but there's only one default group policy. So if you make changes in this default group policy, it is then going to affect all types of tunnels, whether they are remote access or whether they are LAN to LAN. Now, of course, you can configure user-defined group policies. and you can attach them to specific tunnel groups. So for example, when we look at the default group policy, and let's say I wanted to choose that for my remote contractors, I want them to have VPN access at only certain hours. So what I could say, and maybe the VPN or the remote contractors, I have some sort of special certificate for them. So you can get really complicated with the number of rules that you match in order for the user to land on the tunnel, where you could say the user comes in, check their certificate, check certain fields in there. Based on that, I figured out, hey, they're a contractor. I'm going to match them on this particular tunnel group. That tunnel group then calls a new custom group policy that says there's a VPN access hours that is set, and they're only allowed to come into the network from Monday through Friday, 9 a.m. to 5 p.m. or something like that. So you can, kind of snowball these configurations where they have dependencies into each other. But the idea is that it's trying to make the configuration as modular as possible. That if you don't want to make the changes, you can just use all the default settings. But of course, you can make specific changes and then bind them to specific tunnel groups. Okay, for anything that you don't change, that's going to come from the default group policy. The difference here, though, from the tunnel group is that if you make changes in the default group policy, those changes will be reflected into the user-defined group policies. If there is a overlapping between them, so let's say that in the default group policy, I say that there's a default internal DNS server. So I have my default internal DNS server 10.1.2.3. But for some specific users, I want to give them a different one. So if I configure a new specific group policy and then apply it to that specific tunnel group, whatever attributes are more specific there are then going to override the ones that come from the default policy. And you can look at the debug when the user is actually coming into the ASA and getting assigned to the tunnel group and to the group policy. You can see it run through all of the attributes and then return it to the user. So if you're not 100% sure which one is it going to choose, the default or the specific one, you can just look at the debugs and then it tells you what attribute is actually being returned to that user. Now, another thing that gets a little bit hairy with this is that there's multiple places that you can configure some of these attributes. Like, for example, the IP address that you would get or that you could give to a remote access user. So in the case where you could have multiple attributes that correspond, or multiple different attributes that would correspond to the same user, you basically take the most specific configuration in this particular order. So the first one you would check, the most specific one is the dynamic access policy, or DAP. And then it's going to be the individual user attributes. Basically, this stuff would be things like you download from your AAA server. Okay, so the AAA server could maybe have an ACL that you use as the VPN filter for that individual user. That would override an ACL that you have at the group policy level. So the group policy could also be received from the AAA server, or it could be local. Basically, the idea between this is that if you try to centralize these attributes, then it doesn't really matter which VPN server your users connect to. They basically get the same policy, because you may have like clusters of VPN servers. I have a cluster of 5585Xs here and over here, but I have tens of thousands of users. You want to make sure that you don't have to configure all of this stuff locally on all of the boxes. So pretty much all of these options, either in the tunnel group or in the group policy, you can pretty much get any of these from the AAA server. Okay, then lastly, you go down to the tunnel group level. Okay, so let's look at now the specific configuration for this. Now, the overall workflow is going to be very similar to how you would do this in a regular iOS. So first step is to configure phase one. So in our ISACamp policy, what are going to be those four main attributes, which are the authentication, the encryption, the hashing, and then the Diffie-Hellman group. And just like in the previous iOS examples, you do need to make sure that both peers agree on what are all four of these attributes. So depending on the iOS version, depending on the ASA version, depending on the VPN client version, on the end host, maybe not all of them are going to support the same versions of AES. Maybe some of them are not going to support the higher Diffie-Hellman group numbers. So this typically is why you would have more than one policy, more than one ISACamp policy on the ASA. So you may want to say that my most secure policy is going to be to use AES 256 with the largest Diffie-Hellman group, with the largest bit length of SHA, with doing certificates for authentication, and I'm going to put that as my first policy. So whatever users that come in and they match that, they're going to choose the most secure one. But if for some reason maybe they don't have a certificate, then they can fall down to the next one, and so on and so forth, go through the list of policies where you're starting at the most secure and then going down to kind of the last resort ones. But in either case, it's the same logic of iOS, that we're starting with our ISACamp policy to begin with. Okay, then we need to turn ISACamp on, or turn IKEV1 on, because again in iOS this is on by default, but in ASA it's not. Then we specify what is our phase 2 policy. So basically what is going to be the who, what, and the how of the tunnel. So in the crypto map we define what is the peer, or who is the peer I should say, what would be the traffic that's going in there, that's going to be the proxy ACL, and then how would be the transform set. So how are we actually going to encrypt the traffic? Then like in iOS, we bind the crypto map to the interface. Okay, the other step that is different than iOS is that we need the tunnel group. So the tunnel group for LAN to LAN, again, normally would be the IP address of the remote end. This is where we're going to configure our pre-shared key, or if we're doing certificates, say what particular trust point, what certificate authority server are we going to check their certificate against. Now the difference between iOS and ASA here is that in iOS you don't have to use the ISACamp profile, you can just match against the default attributes. But in the case of ASA, you must configure the tunnel group. So the crypto map on its own is not enough to match the policy. You need both of them at the same time. Now in terms of verification, most of the commands are going to be pretty similar here. To look at the config, you can look at show run crypto ISACamp, or run crypto IKEV1. For phase 2, that is going to be the IPsec config, so look at the crypto map, and also to look at the tunnel group. To look at the phase 1 state, that would be our ISACamp SA, so we show crypto ISACamp or show crypto IKEV1 SA. For phase 2, that's going to be the IPsec SA. Okay, for the remote access users, we would say show the VPN session database. So that would show like the actual users that are currently logged into the ASA, and we can categorize that based on what particular type of tunnel. The debugs are going to be pretty much the same as iOS. They're going to be debug crypto ISACamp, or they're going to be debug crypto IPsec. And you'll see here in some of the syntax it says ISACamp or IKEV1, ISACamp or IKEV1. There's a change in the syntax between the versions, and you can see that when I was looking at what their syntax was for the VPN setup for the site-to-site VPNs, site-to-site steps. Sometimes you'll see in the newer versions where it used to say ISACamp, you basically just trade this out with IKEV1. But in most cases, it should accept the syntax either way, and then it's going to convert it towards the IKEV1 syntax in the actual running config. Okay, so let's take a look at our topology that we're going to be using for this. So this is similar to before as we were using for the LAN to LAN connection for iOS. And we're going to be using here router 1 and ASA 3, where router 1 has a loopback interface that is 150.1.1.1. And it's going to be forming a LAN to LAN tunnel to the ASA in order to get access to this segment that is attached to switch 2. So first, let's go ahead and do this on the iOS side. And as we configure the different portions of the tunnel, so as we go through, let me go back a couple slides here. As we go through the ISACamp policy, we're going to look at it on the iOS side and the ASA side, then the crypto map on the iOS side and the ASA side, so we can kind of see them on a one-to-one basis and look at some of the minor differences. What I would recommend not to do is don't do the full config on the router and then do the full config on the ASA. I would try to modularize it and follow the same workflow on a one-to-one basis, top-down. Otherwise, it's very easy to forget one of the steps on one of the boxes, and then before you know it, you have to spend a couple hours troubleshooting why is the VPN not coming up. Okay, so let's start with our first step then, which is going to be the ISACamp policy. Now, what we actually should check before doing that is, like we talked about in iOS LAN to LAN, is the routing process working? Because again, routing and also network address translation, they are separate from the crypto process. So unless router 1 actually has transport to send a packet to that interface of the ASA, and likewise the ASA back, and then of course they're not going to be able to establish the tunnel to each other. So on router 1, we need to see, can we ping this address, or not necessarily ping, we don't need to ping it, we just need to have transport to 136.178.7, I believe. 78.7, which that is the address of ASA3 there. So do we have a route to 136.178.7? Yes, we do. And let's see, I believe the ASAs are set to allow ICMP. Let's ping 78.7. So yes, we do have reachability. Okay, you want to make sure to test this before you go into your crypto config, because there's nothing worse than getting an hour into troubleshooting, then you realize you did some stupid mistake, like the IP address is wrong or the interface is shut down, something like that. So always make sure you build your configs from the bottom up. You test basic layer 2 reachability, test basic layer 3, then you can build the rest of the security-based config. Okay, so again, our first step then is to configure the ISACamp policy. So on router 1, we have our crypto ISACamp policy. We give it a line number, let's say number 10. And we need to specify our 4 attributes. So how are we doing authentication? For right now, we'll just do pre-shared keys. What is the encryption? Let's say AES. What is the group? We'll use group number 5. And what is the hash? Let's say we'll use regular SHA. So if we look at the show crypto ISACamp policy, not profile, policy, we see we have our 4 attributes there defined. And then we have the default for the lifetime. So again, the lifetime, just like iOS to iOS, the ASA will negotiate this down to the lower of the values. So you can put this in, but you don't necessarily need to. You can just leave what the default is. Now on the ASA, if we look at the show crypto ISACamp policy, and I think this one might be, this is going to be Ike v1. Ike v1, actually I think I may need to say show run all. Let's say show run all crypto ISACamp, crypto Ike v1. Okay, so it looks like this one doesn't have any defaults in it. Let's go ahead and define this explicitly then. So in global config, this is going to be the crypto ISACamp policy. And like I mentioned, you can enter this either way, either under Ike v1 or under the ISACamp policy. It still should accept both of the variations, basically from upgrading the config from one to the other. So, and you can see it doesn't take the context-sensitive help, which makes it a little bit confusing, that if you knew the old syntax and you knew it without having to get tab completion or help for it, you can type it in, but then you can see where does it move me to, not the ISACamp config, but under the Ike v1 policy. So the commands are still there, but you're not going to be able to use the context-sensitive help for them. The other variation now is the crypto Ike v1 policy, which you can see does have tab completion and context-sensitive help, but basically means the same thing. Okay, so under here, likewise, we specify what's our authentication. authentication, we're going to use pre-shared keys. What is the encryption? We said to use regular AES. The hashing, we use SHA. And then the group, we used group number 5. Okay, so you can see here on this particular ASA, we don't support all of these other variations for the Diffie-Hellman exchange. So on the router, if we were to say group number 16, then when the router proposes that to the ASA, ASA is going to say, no, I don't support that. The policy or the attributes are not acceptable. So make sure you check for your individual platform and the individual versions that you're using, what are the particular supported attributes there. Okay, if we look at the show crypto IKE v1, is it statistics? So it looks like for this version it doesn't have the verification of the policy on its own. So let's just say show run crypto IKE v1. Okay, so we can see our policy. It shows all of the default attributes as well, which is the lifetime. So if we compare this now to router 1, they're using, router 1 is using pre-shared authentication. ASA, likewise pre-shared authentication. Encryption is AES. Same one here on router 1, and so on and so forth. So again, you could wait until you tried to bring up the tunnel and then look at the debug to see if the attributes are acceptable or not. But it's probably going to save some time just to look at the config when you're building the tunnel on both ends and make sure that all 4 of these attributes match up, which in our particular case, they do. Okay, so the next thing we need to do is to, again, turn ISACamp on. So here on ASA3, this is going to be on our outside interface here, which is gig 0/1.78. If we look at the show IPs, on gig 0/1.78, this is name if VLAN 78. So we would say crypto IKE v1 enable on VLAN 78. And again, the old syntax for this would be crypto ISACamp enable. It's going to take both, and then it's going to change it to the new format. Okay, so that's turning it on. Okay, next step is that we need to define our authentication. So we said that we're going to use pre-shared keys, but what are the specific passwords that we're going to use? Now again, from the router side, assuming we're looking at the crypto map based config here, but when the router applies its crypto map, the source is going to be, by default, it's going to be the outside interface here, which specifically in this case is 136.1.18.1. So this means that's what the ASA is going to match against. Now in the ASA, it's typically simpler than the router because the ASA normally only has one outside interface that we're routing out. So from the router's perspective, we're just going to say that that address there, which is 136.178.7, is going to be the remote end of the pre-shared key. So in global config on router 1, we would say the crypto ISACamp key, let's say Cisco, is for the address 136.178.7 for the address 136.178.7. Now in the case of the ASA, the pre-shared key doesn't go under global, it goes under the tunnel group. So now we need to configure a tunnel group, and we'll say this is our LAN to LAN to router 1, and the type of this tunnel is going to be IPsec LAN to LAN. It says that the LAN to LAN tunnel group, which has a name which are not an IP address, may only be used if the tunnel authentication is digital certificates and or the peer is configured to use aggressive mode. So basically what this is saying to us here is that when the negotiation comes in, the first thing that the ASA needs to do is to associate the ISACamp negotiation with a particular tunnel group. So if we use a name, it means that name has to exist somewhere in the IKE identity that the remote initiator is sending. And we haven't configured router 1 to actually send this keyword L to L to router 1, so that's not going to work. So unless they had a certificate which had this keyword that we could match against, or we configure aggressive mode so they can send the IKE identity, that's not going to work. So in the case of LAN to LAN, like I mentioned before, normally what you should do here is specify the remote address as the tunnel group. So we would say this tunnel group is 136.1.18.1, and the type is IPsec LAN to LAN. Then we specify what are the particular IPsec attributes. Okay, the IPsec attribute specifically that we are concerned about is going to be the IKE v1 pre-shared key. Okay, so we'll say this is Cisco. So if you're used to doing this on iOS, it's a little bit kind of a roundabout way to get this associated. But this is basically like in iOS how we're saying set the peer under the crypto map, and then also where this address is referenced here under the crypto ISACAMP key. Or actually more specifically, this is like the ISACAMP profile on the router. Okay, so now we know the password that we're going to use. Now we can go into our Phase 2 policy. So again, in the Phase 2 policy, there's going to be three main things that we need to think about. So who is the tunnel going to? That's going to be the peer. What is going inside the tunnel? That's going to be our proxy ACL. And how is it going to be treated? That's going to be our transform set. Now in the case of the ASA, we already know what the peer's address is because we've defined this as the tunnel group. But we are going to need to reference this again as we define the crypto map. Okay, in the case of the router, we're going to say we have a crypto map, we'll say crypto 2, that is using, I'll say sequence 10, and this is going to use ISACAMP for negotiation. And we're going to say the peer is the ASA's address, so 136.178.7. On the ASA side, we'll basically do the same thing, crypto map, crypto 2, give it a sequence number. This is using IPsec ISACAMP, and we're going to, actually no, we actually say this all in one line. We need to say set the peer, so the peer is going to be router 1, which is this guy. We then need to set the transform set. That's going to be how the traffic is treated. And then we need to also match the address. Okay, so the address here being the access list. So up to this point, let's say show run crypto. Okay, up to this point, we have the peer defined on both sides. Now let's specify what the particular traffic is going to be. So in this case, the traffic is going to come from, when we're going from router 1, it's going to be sourced from its loopback 150.1.1.1, and the destination is going to be this LAN segment. So 136.1.27.0/24. For the ASA back, remember again that these ACLs have to be reverse images of each other. So the source is going to be the 27.0/24, and then the destination is 150.1.1.1. So again, you want these to be extended ACLs. So on router 1, we're going to say IP access list extended. Let's say router 1 to switch 2. Permit IP host 150.1.1.1, so that's our loopback. And the destination is 136.1.27.0 with a wildcard mask of 24. Okay, on the other end, we have the same thing, but these are going to be reversed. So we'll say access list router 1 to switch 2 is permitting IP 136.1.27.0/24 to the host 150.1.1.1. Okay, then of course we need to match this in the crypto map. So under the crypto map, we need to say match the address, which is the ACL, router 1 to switch 2. And then under the ASA, the same thing, but again, we do this in one line. So we say crypto map the name, the sequence number, then match the address, router 1 to switch 2. Okay, next we need to figure out how are we going to treat the traffic. So is it going to be ESP single DES, triple DES, etc.? That's going to be our crypto IPsec transform set. Crypto IPsec IKE v1 transform sets. We'll say that this is the router 1 to switch 2 transform. And this is going to use, let's say, AES and MD5. Okay, the syntax is similar on the router, but you can't paste it on a one-to-one basis. So it's going to be close, but not 100%. We need to say crypto IPsec transform set. Router 1 to switch 2 transform is going to be ESP AES and ESP MD5. Okay, and the mode again is going to be tunnel for this because we're not transporting the traffic to the router. It's going to be going past the router tunneled towards this destination, the VLAN 27. So last step then is in the, well, technically not the last step. Last step of the crypto map is to then set the transform set. So it may seem a little bit out of order the way that I'm doing this, kind of flip-flopping back and forth, but I would actually recommend to do it this way where you set the attribute on one side, then immediately set it on the other, because otherwise you may skip one of the steps on one of the sides and then you have to waste a bunch of time troubleshooting it. So ideally, of course, it works the very first time, but not normally the case for a lot of these configurations. So crypto map, we match the address, then we need to set the, not the trust point, set the IKE v1 transform set to the name, to the transform set. Okay, so now we have the crypto map configured on both of the sides. Last step is then going to be to apply it. So crypto map, crypto 2 is applied on interface, and in this case VLAN 78. Okay, from the router's point of view, this is going to go at the interface level. So on interface gig 00, crypto map is crypto 2. And again, remember, you can only have one crypto map per interface. So if you have multiple tunnels, you have to sequence them correctly. And sometimes if you put the sequence out of order, you can end up in an issue where the incoming IKE request goes towards the wrong tunnel. Like if you have a dynamic crypto or a dynamic crypto map entry that happens before one of your static entries, you could have like a wildcard match on the dynamic one before it goes down to the static one. So it's just like with the IKE policy, the ISACAM policy. You want to make sure you give yourself enough room in the line numbering here for the crypto map that if you need to change it around later, add a sequence before this or after this, that you give yourself enough space for it. Okay, so let's go ahead and test this out now. So from router 1, let's ping. And our destination is what here? Let's say 136.1. And let me check the switch, what its address is. It is 136.127.8. So on router 1, we're pinging 136.127.8. And again, remember, we have to source this from whatever our source of the interesting traffic is. So in this case, our loopback. Now if we look at the show crypto ISACAMP SA, we see that the phase 1 tunnel was correctly established. It says it's in quick mode idle and it's in active state. If we then look at the show crypto IPsec SA for our phase 2 policy, it says that with crypto map crypto 2, we have a tunnel that goes towards the ASA, so 78.7. Port is 500 because that's talking about our phase 1 ISACAMP is UDP 500. And then for our security associations, again, we should see two of these. We should see an inbound SA and also an outbound SA. So again, with phase 1 ISACamp, it's one bidirectional security association. With phase 2, it's two separate unidirectional ones. So in this case, the ASAs in the transit path, so ASA 4 is not doing any filtering right now, but if this interface was inside, like security level 100, and this one here was outside at security level 0, we would have a problem where the traffic goes out, it tries to return, but then this guy drops it. Now also notice here what is a little bit different than the normal ASA rules for ASA 3, that we are allowing now traffic sourced from router 1 to come in on this outside interface and then to enter towards this inside segment. And if we take a look at ASA 3 and look at the show nameif, we can see that gig 01.78, this is security level 0, so that's the outside. VLAN 27 is security 100, which is on the inside. And normally we would assume that you can't do this. Like if we were to, on router 1 telnet to 136.1.27. Was it 27.8? Telnet 136.1.27.8 with a source interface of our loopback. We can see we can reach switch 2. Normally the ASA would not allow this because we're moving from security level 0 to 100. We're going lower to higher. Normally this is going to be denied. But in the case of IPsec tunnels, the tunnel group is considered to be security level 100. So it's automatically a trusted interface where we do not need an access list exception to say we want to permit the traffic in from that. Now, there was in older ASA versions a command that you needed to do in order to allow this, and I'm not sure if this version still has it, which is sysop connection permit VPN, which this should be the default value. And let's say here show run all sysopt, which it is, sysop connection permit VPN. Basically, this means that if traffic comes in on the VPN tunnel, you're going to treat it like it's security level 100, that it's coming from a trusted interface. If we were to remove this and say no sysop connection permit VPN, then when router 1 sends this traffic through, it's going to be treated as if it is coming from the outside interface. So in this case, then we would need specific ACL entries on the ASA, and we could see this now if we turn logging on. Logging to the console at level 7. When we now initiate this traffic from router 1, we should see that the ASA says it's denied because it says it's coming on interface 78, which is the outside. But really this is coming from the VPN tunnel. So assuming that they didn't turn this off, you normally want this feature on, sysop connection permit VPN, then you don't need to do any ACL exceptions for permitting the traffic in the tunnel. Now again, you can still edit the group policy and configure a VPN filter, and that would say inside on a per user basis, you can permit or deny the traffic from coming in that particular tunnel. Okay, we can also see here from the ASA when we're logging the traffic on, you can see it starts to get pretty noisy actually here as to it processing all of the IPsec packets. So compared to the router, it gets a little bit more difficult to sort through some of these debugs. And let's look at what this would normally look like on the ASA. So let's say this on router 1. Let's clear crypto ISACamp. That's going to delete our phase 1. And clear crypto SA, that's going to delete our phase 2. So now if we show crypto ISACamp security associations, it says this one deleted, it has no state. If we show crypto IPsec SA, There's no inbound security association. There's no outbound security association. Okay, same thing on the ASA. Let's say clear crypto ISACamp and clear crypto SA. Clear crypto IPsec SA. Okay, now let's look at the debug crypto IKE v1. And the debug crypto IPsec. Okay, so just like on the router, these would respectively be the phase 1 debugs and the phase 2 debugs. So from router 1, let's go ahead and initiate the session again. Let's just do a basic ping. So ping 136.127.8 from our loopback 150.111. And let's turn logging off, no logging on. And let's look at this from the top down, exactly what happened in the negotiation. So you can see it's a lot of output here. First thing, it starts saying that we're building a UDP connection. No, that's for something else. That's for time. We're processing a security association payload from router 1. And what we first need to see is did the connection land on the tunnel group? Okay, this tells us, based on the inbound IKE request, did we expect to accept this tunnel? So this is coming from a remote access user, would be based on their certificate, or maybe based on their group name, like the EasyVPN group name. And we want to make sure that this is the first thing that happens with phase 1, that it is correctly associated with the individual tunnel group. Okay, once it's associated, then we can go on with the rest of the phase 1 negotiation. So we should see here that it says, let's see, I may need to actually set the debug level higher. Let's say debug crypto IKE v1, let's say at level 10. And these levels are kind of hit and miss with the ASA. A lot of times, if it's too low, it's not enough, and if it's too high, you just get a full packet level dump, which is a lot of the time too much for this. So let's delete the SAs and then restart it again. So what I'm looking for here is the IKE proposal, which is, of course, going to be before the phase 2 negotiation. Here it says IKE SA proposal number 1, transform number 1 is acceptable. It matches global IKE entry number 1. The problem is here it doesn't specifically tell us what is IKE entry number 1. It would give more information if the transfer, or not the transfer, if the policy did not match. Then it would say the attributes are not acceptable, and specifically say what is not acceptable, and that's going to lead us towards further debugging for the phase 1 policy. Now, like we also saw on the routers, if there's a mismatch in the authentication, you're going to get a similar syslog output that says that the packet is malformed, the IKE packet is malformed, because again, the VPN server doesn't know if the authentication is wrong, or the packet got corrupted, or someone intercepted it and then modified the packet in transit. But from here, what we can see that is, let me turn logging off again, no logging on. What we want to see is that And let me actually copy this out to my text editor because you can see how much output just for one tunnel. And as you can imagine, if you have lots of tunnels terminating on the ASA, it gets really hairy to try to debug this. So in reality, you probably would want to send this either to syslog, or within the scope of the exam, you're probably not going to have a syslog server, but you may want to send it to the buffer, and then from the buffer, you can try to sort through it from there. So let's say okay, so let's start from here. So it says the connection landed on the tunnel group. This means, again, that we found the particular tunnel based on the IKE identifier. So this is correct. Then the next step should be that we accept the proposal. Okay, so we accept the proposal. Then phase one is completed. So it doesn't necessarily say here that authentication is successful, but simply based on the fact that phase one is done, it means that your authentication is fine, that all of those four attributes are fine. We should then see them do the IPsec proposal. So it says processing the SA payload. The SA payload is matching crypto map number 2, and the proposal is acceptable. It says matches global IPsec SA entry number 10. So again, if you did have a problem here, then it's where the debug is going to really give you more information. It'll tell you specifically in your ISACAMP policy or your IPsec policy what are the individual attributes that the IKE recipient or the IPsec responder did not want. Then we can see they're actually forming the security associations. Then we're exchanging our proxy ACLs. So if there was a problem with the access lists, this is where we would see it here. Then our final output is down here. Phase 2 is completed. But just like on the router, you can tell this without having to look at the debug. With the show crypto IKE v1 SA, which used to be the show crypto ISACAMP SA. Show crypto ISACAMP SA. It says that the state is active, which is correct here. That's the particular peer. It's a LAN-to-LAN tunnel. If we then look at the show crypto IPsec SA, this is pretty similar to iOS's output here, where we have our local address, current peer, this is router 1. This is our proxy identity, so where's the traffic coming from on our end, and where is it going to on the remote end. You can also see here it lists the protocol and port number, so if we were saying just TCP port 80 or UDP 123, those would be listed as the protocol numbers, and then we can see the specific counters. So again, if there was a problem in the data plane, we could parse the show crypto IPsec SA pipe include NCAP or DCAP, and then this is going to give us the individual packet counters for that IPsec tunnel. So again, if you see on one side that you are encapsulating, but on the other side you're not decapsulating, that would mean that there's something wrong on the transit path on the way there. Or if the other side is decapsulating and encapsulating back for the return flow, but you don't get the decapsulate back, it means that something is filtered in the transit path from the destination back to the source. So let's look at our final config here now on the iOS side versus the ASA. So let's say show run section crypto on router 1. So on router 1, we have our ISACamp policy. We then have our authentication for ISACamp. We have our transform set. We have the crypto map, which is matching the peer, so who's the end point of the tunnel, how is the traffic being traded, and then what is the traffic, which is the access list. And the access list show run section access list. So from our loopback to the remote peer. So on the ASA, it's going to be pretty close to this with the exception of the tunnel group. So let's say show run crypto. So we have first our ISACamp policy. So ISACamp policy 10, which is matching our 4 values and then also the lifetime. Again, with the ASA, the pre-shared key is going to be under the tunnel group. So the tunnel group is specifying the IP address of the remote end. Okay, so this is kind of the equivalent here of the crypto ISACamp key. So for this particular peer, this is their pre-shared key. That would be Cisco there. Then we have our transform set, which again is saying how are we treating the traffic. What is the traffic is going to be the access list. Let's say show run access list. The access list, we have the crypto map that's saying match the ACL, set the peer, set the transform set. Then the crypto map is applied on the interface. Well, technically this isn't global, but it's referencing the interface. And then lastly, we're enabling ISACamp or IKV1 at the interface. So pretty much everything is the same here with the exception of the tunnel group and then of enabling the ISACamp. But again, for these configs on the ASA, I wouldn't necessarily recommend memorizing all of the syntax because it's very, very easy to leave out one of the individual pieces where you could simply look at the VPN setup or look at the show run all tunnel group, show run all group policy, and then that's going to show you pretty much what are all of the parameters that you need.